In this video, we are going to look at solving a system of two equations with two unknowns using the elimination method. And there are three methods for solving a system of equations, three common methods, which are the graphing method, the substitution method, and the elimination method. And I cover the graphing method and the substitution method in different videos. This video, we're going to focus on elimination. And maybe in another video I'll look at how do we choose which is the best method to use of all three. So with the elimination method, we have some steps we need to follow. And the first step is to make sure that the variables are lined up and the equal sign is lined up. So if we look over here, we've got a y equals x plus 7 and 1/2 x plus y equals 1. And we don't have step 1 taken care of yet. What we need is we need these to look the same. So usually we do the x term, then the y term, then the equal sign. So I'm going to take this blue equation here and I am going to rearrange it so that it is in the same order of the red equation, and that'll take care of step 1. So what I'm going to do is I'm going to subtract x from both sides, and I'll just write it down here. So if I subtract x from both sides, I would get the opposite of x plus y equals 7. Alright, so that's what I mean by line up the variables in the equal sign. So notice we've got the x terms, the y terms, the equal sign, and then your constant terms over here. So we got step 1 taken care of there. Alright, so step 2 is to make the coefficients of one variable opposites. Alright, so remember what coefficients are. Those are the numbers that are multiplied by the variable. The coefficients on the x terms are 1/2 and -1, and the coefficients on the y terms are 1 and 1. So we want to make those opposites. And by opposites, we mean, they have the same absolute value. So it's like 3 and -3, 1 and -1. So we're really close to having our y coefficients opposites. And it doesn't matter which one you do. You want to just do the easiest one. But I have a 1 and a -1. I have a 1 and a 1, and what I want is a 1 and a -1. So in order to make that happen, what I'm going to do is just pick one of these two equations, doesn't matter which one, and multiply through by a negative. So let's say I take this blue equation right here, and I multiply everything by a -1. All right, so that's going to make this a positive x, and this is going to make this a -y, and a -7. All right, so now I've got the coefficient on the y is 1, and this y is -1. So now we have step 2. All right, what's the main reason we wanted to do that? Well, the main reason we wanted to do that is because when we go to step 3, which is adding the equations together, one of the variables is going to drop out. Okay, so if we add these equations together now, notice how they're all lined up. That's why we had to do step 1. We have a 1/2 x plus x. Remember, this is 1x, so a 1/2 x plus 1x would be 1 and 1/2 x. And what happens when we add the y terms together? They drop out. Okay, that's why you have to have step 2 done, because you want one of those variables to drop out. And 1 plus -7 is -6. I want one of those variables to drop out because now I created an equation with one unknown, and I can solve that, right? I can divide both sides by 1/2 and figure out how many times 1/2 goes into -6. And I'll have my value of x. So x equals, where it goes in 4 times, right? So -4. Okay, we added the equations together, and then we solved that and came up with x equals -4. So now we know what x is, and we want to figure out what y is. So we're going to plug our known value, which is -4, into one of the original equations. Oh, let's just do this top equation here. So here I have my original equation, y equals x plus 7, and I'll plug in the -4 for x. So I get y, oh, that looks funny. That's supposed to be a 7. There we go. So y equals -4 plus 7, which gives me y equals 3. So there, boom, I have my answer. I know x is -4 and y is 3. And that's the solution. Remember, a solution means values of the variable that make the equation true. So if x is -4, I plug that in here. -4 plus 7, y is 3. So x is negative 4, y is 3 makes this equation true. All right, let's check the other one. Let's make this red since we're going to check the red equation. So I'm checking my solution now. I checked it for the blue one. I could kind of do that in my head. And some of you could do the red equation in your head too. That's fine, but we'll write it out. So I'm checking if I let x be negative 4, because that's what I got for my solution. And I let y be 3. Does it come out to be 1? That's what we're checking. Let's see, we got negative 2 plus 3. Yep, that's 1. So that means that x equals negative 4, y equals 3 makes the red equation true, and it makes the blue equation true. Therefore, it is the solution to the system. And we usually write our answers as an ordered pair, like that. And that is our solution. Now, if we graphed these two lines, this is where they would cross, and that's the graphing method. If you're interested in that, I have a video on the graphing method as well. All right, so if you need to refer back to these steps, then just rewind the video and check that out. But let's go ahead and look at another example. Okay, so in this example here, if you think you've got it, and you want to pause the video and give it a try, go for it. In this example here, we have the variables lined up, so that's good. We've got our x terms, our y terms, our equal sign. That's all great. Remember, the next step was to make the coefficients opposites. So here I have a 2. What I would need here is a negative 2. Here my coefficient is negative 3, so what I would need here is a 3. All right, so you've got two options, and it really doesn't matter which one you do. To make this 2x, let's say I wanted to make this, negative 2x, I could multiply this entire equation by negative 2. All right, that would give me negative 2x right here. My other option would have been to multiply this top equation by a positive 3. And maybe I'll do that. Maybe we'll do it both ways just to show it comes out the same. Okay, so if I multiply this the red equation by negative 2, I get, make sure you multiply everything, right? The whole equation. We get negative 2x plus 6y equals negative 16. The top equation, I'm just going to keep that the same. I don't need to do anything because I already have my 2x there. All right, so notice I've got the 2x and the negative 2x. That's what I need before I add these together so that those x's drop out. So here I get 7y and negative 7. When I add those together, divide both sides by 7, and y is negative 1. All right, so now I take this negative 1 and I'm going to plug it back into one of these original equations to find x. Let's just do the top one. Doesn't matter which one. Try them both if you like. So I'll put a negative 1 where the y was, all right, and just solve it. So add 1 to both sides, divide both sides by 2, and I get 5. So there's my answer, 5, negative 1. And you could check it. Let's see if we put 5 in for x into the red equation, and 3 times negative 1 is negative 3, so minus a negative 3 makes a plus 3. So we got 5 plus 3, that's 8. That works. All right, so just for fun, I'm going to solve this equation, this system again, but I'm going to multiply the top one. Let's say I take the top equation and I multiplied that by 3 to get it so that it's opposite of the negative 3y in the red equation. That would give me 6x plus 3y equals 27. So now I'll take the red equation and write it under here and add them together. And I would get 7x equals 35. So x is 5, which is exactly what we got over here, right? Just by getting, oh, that looks yucky, 5. There we go. Just by making the y's drop out, you find out what x is first. Over here, when we had the x's drop out, we find out what y is first. But it doesn't really matter which one you find first, right? So if you were doing it this way, you'd still want to go and plug 5 in. Let's plug it into the blue equation and figure out what y is. And it should come out to be negative 1. let's see, we get 10 plus y is 9, subtract 10 from both sides, and we get -1, right? So it doesn't matter. You can make either variable drop out, and you're going to get the same answer. All right, I have one more example that I'll go through. Now, this one is different than the ones we've done before because I can't just multiply one of these equations to get the opposite of another one easily. I mean, you could multiply it by some fractional value, I suppose, but it's a little easier if you multiply both of them. So if you think you want to give this a shot, pause the video and give it a shot. Okay, so it's kind of a least common denominator or a least common multiple situation. Let's say I wanted to get the x's to drop out, and my coefficient is 8 and 6, -8 and 6. All right, so I have to think, like, what's the smallest number that 8 and 6 both go into? And in your mind, you should be thinking, okay, let's say I got 6, 12. These are the numbers that 6 goes into. And the numbers that 8 go into, I have 8, 16, 24. All right, 24 is the least common multiple of 8 and 6. It's the smallest number that 8 and 6 both go into. So if I wanted to get my x's to drop out, I want to make these 24s. It's the same thing here, 6 and 4, also the least common multiple. Oh, no, it would be 12, right? 12. It's not 24. You could make them both 24s, but and it would still work. It's just the numbers would be bigger. It doesn't have to be the least common multiple, but it will be easier if it's the least common multiple. All right, so let's go for this 24 business. So I'm going to get the x's to drop out, okay? So I'm going to multiply this top equation by 3, which will make -24x. And I'm going to multiply this bottom equation by 4, which will make this +24x. And then my x's will drop out. Now, multiplying by 3 and 4 is going to change the coefficients on the y's, and it's going to change these, but I don't really care about that. My goal is to get these x's to drop out, and whatever happens with the y numbers, the coefficients, and the constants is what's going to happen, and that's fine. I'm not worried about it. Okay? It doesn't concern me. All right, so what do I get? I get -24x plus 3 times 6 is 18y. Remember to multiply everything. Let's put this over here. Equals, let's see, 3 times -10.5 would be -31.5. Now, for those of you that have done the graphing method, this is a great example of where you wouldn't really want to graph these lines and see where they cross, right? The elimination method is a lot cleaner. So if I multiply all the red equation by 4, I get 24x plus 16y equals 40. Okay, my variables are lined up, my equal signs are lined up, I have my opposites for my coefficients. So now when I add them together, one of my variables should drop out. If you're adding them together and one of your variables is not dropping out, then you're doing something wrong, right? That's the whole point of the elimination method, is to make it so one of the variables drops out. What is that? 8.5. Okay, this is coming out a little weird, but we'll just keep going. Don't panic. Sometimes students look at problems, and if the numbers aren't nice, they think they did something wrong. And I suppose it's always good to check, but okay, I think if you put that into your calculator, you get 0.25 or 1/4. So I'll just write it as a fraction. 0.25 is fine if you like decimals. Okay, cool. We have the value of y. So remember now we need to find the value of x. A solution to a system, when we solve a system, the answer is always going to be an ordered pair. We need an x and a y value. A y value is not enough for the solution. It has to be an x and a y value. So we're going to plug 1/4 back in for one of these y's. Let's just do the red one. So now we're going to find x by taking 1/4, which we know is the value of y, and plugging it in for y. And that will allow us to find x. So we get 6x plus 1. That's coming out kind of nice. And subtract 1. Divide by 6. I think that's 1 1/2. 1.5, 1 1/2. Okay. So I'm thinking my answer is 1 1/2 1.5 comma 1/4. So I could check that. If that is the solution, then when x is 1.5 and y is 1/4, it will make both of these equations true. All right, so let's go ahead and check that. It's always good to check. I know sometimes when you're done, it's like, I'm done. I just want to go on to the next problem. But, you know, that's kind of the cool thing about these problems on a test or a quiz or something. You can always check your answer and see if it's right. You don't have to wonder. So I'm going to check the blue equation. Let's see, -8 times x, which is 1.5, plus 6 times y, which is 1/4. I need that to come out to be -10.5. Let's see if it is. Let's see. -8 times 1.5, that would be -12. And 1/4 of 6 would be 1.5. I think so. You could use decimals if you want, if you're using your calculator. And that does come out to be -10.5 if I add those together. Cool. All right, so it works for the blue equation. If it's going to be the solution to the system, then it also needs to work for the red equation. My solution needs to make the red equation true. So the red equation is 6 times x plus 4 times y. And I need that to come out to be 10. Let's see if it works. Let's see, 6 times 1.5, that would be 9. Half of 6 is 3. Add that on to 6, you get 9. And 1/4 of 4 is 1, and certainly that is true. Awesome. So now I can be super confident that my solution is correct. All right, so you have these three ways to solve a system of equations: substitution, elimination, and graphing. And elimination does turn out to be one of the most used, along with substitution, when you're solving systems and story problems and stuff. The key for knowing when to use elimination, that elimination is going to be a good idea, is when you do have the variables lined up like this, and you have your equal signs lined up. A lot of story problems that you do, application problems, after you write your system of equations from the application, from the story, your equations look like this. And that's usually a sign that, hey, elimination is going to be the best way to go.